Hello, this is Mr. Collier, and today we're looking at some trig graphs. So they're easy to generate if you understand the unit circle. Okay, so we know that, let's write out the coordinates. 1, 0 here, 0, 1, negative 1, 0, and 0, negative 1. So for example, if you want to generate the graph of y equals sine x, and let's do this in radians. Okay, so this is pi over 2, 3 pi over 2, 2 pi. All right, so we know that the sine is equal to the y value on the unit circle. So sine of 0 is 0. Let's do some pink. And let's make some tick marks here. So we're going to go pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi, and then you can go like 5 pi over 2 if you want to continue on going, right? And then you can go negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and so forth. Okay, so if you look at the unit circle here, the y value is 0, so that's where sine starts, 0. Then at pi over 2, we get a maximum at 1. So this goes up to 1 and negative 1. So sine pi over 2 is just the y value on the unit circle, which is 1. Then it drops down to 0. Then it goes down to negative 1. Then it goes up to 2 pi, or up to 0 at 2 pi, right? The y value is back to 0. And the y value is 1. So keep cycling between, 1 and 0 and negative 1. This could be a bit more smoother, but that's the way it looks, right? Same thing if we go backwards, we go negative pi over 2, we have negative 1. And then it goes 0, 1, 0, negative 1, 0. It goes on and on like that. Okay, this is a bit more smooth. This is more what it looks like, right? So that's sine. And if you want to do the cosine graph, then we look at the x value. So cosine starts at 1, then it goes to 0, then it goes to negative 1, then it goes to 0, then it goes to positive 1. So it looks very similar, but it's off by 90 degrees, or pi over 2 radians, right? Okay, so that's what the graphs of sine and cosine look like. Notice their range for both of them is y is less than or equal to 1, or y is between negative 1 and 1, right? So that's the range for both those functions. Anyway, let's look at general equation of a sine function, and this could very well be cosine as well, right? So we already know from transformations of functions that A is the vertical stretch. We call that amplitude in terms of waves. Okay, waves have a different language. Amplitude is this height. That's the amplitude. Okay, it says affects amplitude because actually it's not equal to the amplitude. The absolute value of A is equal to the amplitude, right? So if you have a negative 5, that means the amplitude is 5. Amplitude. Okay. And you might have heard of AM radio. AM radio refers to amplitude modulation, so the height of the waves are different in AM radio, or the height of the waves determines what the radio signals are. Okay, we have B is like a horizontal stretch, right? Okay, so we say it affects the period. We have this equation here, period equals 2 pi over B. This also means B equals 2 pi over period. Okay, so it's a very important little formula that you use to figure out the period if you know the B value, or B value if you know the period. Okay. C is obviously a horizontal translation. Okay, and this, if it's in factored form, then that's the horizontal translation. And D is the vertical translation, but in terms of waves, we call it also the principal axis. Principal axis. It's the line that goes right in the middle of the wave, right? So the whole thing goes up 1, for instance, if you have a plus 1 at the end. So the middle of the curve goes up 1 as well. Okay, let's look at some actual graphs. Okay, there's sine and cosine like I just talked about earlier, right? So cosine starts off at 1 and sine starts off at 0, and then it cycles between 0, 1, 0, negative 1, and so forth. It's easy to regenerate this if you forget, because if you know the unit circle, like I talked about before. Okay, let's look at tangent theta. Okay, so tangent theta, again, let's draw that unit circle. This is 1, 0. This is negative 1, 0. Sorry, 0, negative 1. This is 0, 1, negative 1, 0. Okay, so tangent of 0 is 0 divided by 1. It's the y value divided by the x value. 0 divided by 1 is 0. And if you go up here, it's actually 1 divided by 0. Okay, 1 divided by 0 is undefined. In terms of the graph, you get a vertical asymptote. Okay. You may recall from the 45-45-90 triangle, or the pi over 2 triangle. You have the ratio 1, 1, root 2. Tangent of pi over 2 is, sorry, pi over 4. That's pi over 4. The tangent of pi over 4 is 1. So right here is pi over 4, right? So we have 1 right there. Okay, and similarly, CAST, tangent of negative pi over 4 is negative 1. So we have these points right here, and we have another asymptote here because tangent negative pi over 2 is negative 1 divided by 0, which is undefined. So you have asymptotes like that, and it looks like this here. Okay, so you get an asymptote at x equals pi over 2 and x equals negative pi over 2. And you can continue on with the same pattern. At x equals 3 pi over 2, you got another asymptote. And the curve looks like this, right? You get a bunch of these little waves. Okay, let me put another one over here. Let me do 1 and negative 1. So the curve looks like that. Okay. Okay. Next, let's look at secant. Recall secant is 1 over cosine x, right? 1 divided by cosine x. So let's draw cosine now in pink. Let me do it in blue, actually. Okay, so cosine starts off at 1, then it goes to 0, then it goes to negative 1. So it looks like that. Okay. Kind of missed that last one. So this is cosine. Okay, so 1 over cosine, secant, is just going to be 1 divided by the y values here, right? So 1 divided by 1 is 1. 1 divided by 0 gives you an asymptote. 1 divided by negative 1 gives you this, right? Negative 1. You get another asymptote here. You get another asymptote there. Yeah, so there you get negative 1, there you get 1, right? So if you take a number like right here, somewhere along here you got it like negative half. 1 divided by negative half gives you negative 2. Somewhere along here you got like negative 1/3. 1 divided by 1/3 gives you 3. So it looks like you're going to get a curve like this. It's not quite a parabola, but it's very similar to a parabola. So you get these shapes. Okay. So this is what the graph of secant looks like. So the range is kind of interesting. The range is y is less than or equal to negative 1, union y greater or equal to 1. Or you can write it like this, negative infinity, oops, that should be open bracket, negative infinity to negative 1. That should be square bracket because it includes negative 1, union 1 to infinity. Okay, that's the range. The domain is all x except for the set of numbers that are multiples of pi over 2, right? This pi over 2. This is 3 pi over 2. So multiples of pi over 2, we can write it as pi n over 2, where n is a integer, right? That's how you write multiples of pi over 2. Okay, let's look at cosecant, which is 1 over sine. So it's going to look very similar, actually, right? Sine starts off as 0, then it goes up to 1, then it goes to pi, it goes to 0, negative 1. So it looks like that. Okay, not bad. That was nice and curvy. So 1 over sine x, 1 divided by that gives you an asymptote. 1 divided by 1 gives you 1. And this gives you an asymptote here. Let's draw on all the asymptotes. So again, you're going to get a very similar shape to the secant function, right? Okay, and the exact same range as the other one, and the domain is very similar. The domain is multiples of pi, right? Okay, cotangent is 1 over tangent, of course. So let's remind ourselves what tangent looks like. Remember, tangent has vertical asymptotes. Here. And tangent has 1, 1, and negative 1 there. Let's draw that in. Okay. All right, so there's tangent. So 1 over 0 gives you a vertical asymptote. So here's our vertical asymptotes. 1 over 1 gives you 1, so that's going to be the same. 1 over like half, somewhere along here, gives you 2. 1 over like 3 gives you a third, right? 1 over 3 gives you a third, so these are going to give you closer and closer to, oh yeah, that's right. And then 1 divided by the asymptote actually gives you 0, right? So we actually get this kind of curve right here. Okay, so we get the same thing here. Go through that point. Here is the x-intercept, and it goes like that. So it's just like a reflection, really. No, I didn't do that one correctly. Goes down here, then hits 0, then hits this one, and goes like that. Okay, it goes down here, hits 1, hits 0, hits that one, goes down like that. Okay, so that's the graph of cotangent x. Okay, let's check out this here. Find the period of all the following functions. Assume radians. You should always assume radians, actually. So recall the period equals 2 pi over the b value, which is 3. So the period is 2 pi over 3. What that means is the entire cycle finishes by the time we hit 2 pi over 3. Okay, so that's the period. Next one, yeah, the period is 2 pi divided by 1/3, which equals 6 pi. 6 pi. That means the whole function gets finished by the time we get to 6 pi. Okay, the whole function is from 0 to 6 pi. So right in the middle is 3 pi, for instance, and you got 3 pi over 2. That makes sense because it should be more stretched out, right? 1/3 there should be a horizontal stretch of 3. So the curve should be stretched out by a factor of 3. And it now goes up to 6 pi instead of 2 pi. Okay, cosine pi theta is the period, well, the period is 2 pi over b value, so it's just the period equals 2. So it goes like this and stops at, oh, that's cosines, right? Cosine starts at 1, comes down, goes up, and ends up at a maximum again at 2. Okay? So this is like 1, I kind of didn't draw it to scale, half and such. Okay, state the period, amplitude, phase shift. Phase shift is the horizontal shift, and vertical shift for each graph. Okay, so here the amplitude is just how high the curve is going to be. And that's going to be 3. It's like the vertical stretch. Amplitude equals 3. The period is 2 pi divided by 2, so it's just equal to pi. Okay, this is amplitude equals half. Period equals 2 pi divided by 3. And the vertical shift is down 1, right? So the whole graph is down 1. Here the amplitude is the absolute value of that number, which is 2. Okay, but the curve is flipped around as well. The horizontal shift, or the phase shift, equals pi over 4 to the right, right? It goes pi over 4 to the right. The vertical shift is just positive 3. Okay, let's do some actual graphs, or let's actually look at a graph and get the equation in terms of sine and then cosine. So if we want to get this in terms of sine, let's get the things first, like the amplitude. The amplitude is from the middle to the top. Normally it goes up 1. This is up 2, right? You could also do the maximum minus the minimum divided by 2. That's like a general formula, right? Because this is 5 and this is 1. 5 minus 1 divided by 2 gives you 2. Okay, it's this distance right here is 2. Okay, that's the amplitude. I guess the b value is 2 pi over the period. Okay, now let's look at this. The period is, we have a maximum here at x equals 1 and a minimum at x equals 4. So this distance is 4. That's half the period, so the period is going to be 8. So 2 pi over 8 is pi over 4. So pi over 4 is the b value. C value, remember we're looking at y equals a sine bx minus c plus d, right? C value is the horizontal shift. Now sine usually starts at 0, okay? Sine usually starts at 0. So now we have well, it touches the principal axis right here, so it's really shifted to the right one. So C is going to be a negative, or actually positive 1, because this is already negative. So C is 1. Okay, the D value is the vertical shift, or the principal axis, which is 3. Okay, you can also say max, you get the average of the maximum and minimum. Max plus min divided by 2, which is 5 plus 1 divided by 2 is 3, right? You can clearly see in the graph that it's 3. Okay, let's go back here. I made a tiny bit of a mistake because, you know, sine normally goes up like this, right? But this one's flipped upside down. So the a value you can consider to be negative 2. Okay, so if you use all these parameters, then you need your a value to be negative 2. So the equation is negative 2 sine pi over 4 times x minus 1 plus 3. Okay, cosine would be very similar. So for cosine, you can call it negative, let's just hold up on that for a second. Cosine, actually maybe you want to, cosine usually starts off at 1, and we can think of this as shifted just to the left 1. So we can use a positive 2. And cosine, this has to be the same because, yeah, obviously the period is going to be the same whether it's sine or cosine. This one we can call it positive 1 and plus 3 as well, right? Okay. Actually, there's an infinite number of possible answers because you could say this is shifted to the left 1, or you could say it's actually shifted to the right by a certain number because you have a maximum over here, right? Or you can pick the next maximum, or you go backwards and do 2 maximums backwards. So there's many, many different ways you can write the equation, but those are probably the simplest. Okay, let's look at the next one. Find the equation. Okay, so we need to find the amplitude. The amplitude is obviously 2. All right, I think we'll use sine here. So the amplitude is 2. It's not shifted right or left. the period, or the b value, is 2 pi over period, which is, actually, let's not use 2 pi in this case because it looks like it's in degrees. So if it's in degrees, we'll use 360 is the same as 2 pi over the period, which is the entire cycle, is 360. So it's actually equal to 1. So this is a normal sized sine wave, I guess. The whole thing is up 1 though. So we say is y equals 2 sine x plus 1. Okay, now let's look at cosine. We can consider this to be a cosine function that shifted over to the right 2. So we could say it's y equals 2 cosine x, that's not shifted over 2, this is 90 degrees, so minus 90 plus 1, right? That gives you a cosine version of the equation. Okay, next, this one has an amplitude of 1, and the b value, so the cycle is also 360, so it's normal, right? It's 360 divided by 360, which equals 1. So the b value is 1. If we think in terms of sine, we can say it's shifted this way 90 degrees, right? And up 1. So the whole thing is y equals, a is 1, so it's just sine x, or sine, b is 1, so sine x plus 90, that shifts it over to the left 90, plus 1 because the whole thing is shifted up 1. So that's the equation in terms of sine. In terms of cosine, it's starting where we want it to be, so there's no horizontal shift. So we just say cosine x plus 1. Okay, let's go to the next one. This is obviously the principal axis right there. So the whole thing is shifted up 1. The amplitude is 2. If we're thinking in terms of sine, we can say that the graph is shifted to the left by 45 degrees, right? Because that would be the normal starting point for sine. So y equals 2 sine, because the amplitude is 2. Oh, let's get the b value. B is 360 over the period. The period is, let's go from maximum to maximum, 180. So the b value is 2. So this is 2 times x minus negative 45, which is just plus 45. That shifts it to the left 45 degrees, plus 1. Okay? Cosine, looks like for cosine there's no horizontal shift, so it's just 2 cosine 2x plus 1, right? So that's it for the cosine. This one, okay, we've got a principal axis here. We can say it's a sine curve that shifted to the right 180, or just flipped upside down. So we can put a negative in front, right? The amplitude is the same, so we just say it's negative sine x. Actually, let's get the period, sorry, or the b value. The b value is 360 divided by the period. Period from this crest to this crest is 360, so it is 360 over 360, it's just 1. So we got x. If we use negative, then we don't have a shift at all. So it's just, oh, so it's minus 1, of course. Okay, or you could say it's shifted, it's a sine curve shifted over 180, right? So you could say it's sine times x minus 180 minus 1. Those are the same, they're equivalent, exactly the same graph. For cosine, you can say it's a regular cosine function shifted over to the left by 90. So you can say y equals cosine x plus 90 minus 1. That gives you the same exact graph, right? Okay, next, let's check out, well, we can see where the middle is. The amplitude is 2. For sine, we can say it's shifted over to the right by 45. So y equals 2 sine. Let's get the b value. B equals 360 divided by 180, which equals 2. So it's going to be 2 times x minus 45, shifts it over to the right 45, minus 1, gives you the entire equation. For cosine, we can say just cosine is just flipped upside down. So it's negative 2 cosine 2x minus 1, right? Okay, next, this one has a b value. The whole thing is one entire length of the curve, right? So that's like 720. That's the period. So the b value is half. It's obviously down 1. For sine, it looks normal because it's going through the principal axis right there. So this is going to be y equals sine half x minus 1. Cosine, you could think of it as shifted over to the right by 180. So cosine half times x minus 180 minus 1. That gives you the graph in terms of cosine.